Hello students, in this video we'll see an example of figuring out which of three functions is a function, which is the derivative, and which is the second derivative. So in this graph, we have f of x, f prime of x, and f double prime of x. Which of A, B, and C match A, B, and C to f prime, and f double prime? Match f prime, and f double prime to the graphs A, B, and C. So let's make some observations about this. The graphs give us a lot of clues. Notice one thing we can say on graph B is that B has a local minimum at the origin. B has a local minimum at the origin. So whatever the derivative of B is, the derivative of B at 0 has to be 0, because there's a local minimum there. It looks like this function A has a discontinuity, or an infinite discontinuity at the origin. The limit, as x approaches 0, of the graph of A is not defined, does not exist. So the A's derivative has infinite slope there. So A comes from something where there's an infinite slope. So let's use that to our advantage. Okay, so let's look at this graph carefully now. So if we look at the graph of C, we see that the slope of C at the origin looks like it's vertical. The slope of C and furthermore, I know that C of 0 is equal to 0. C of 0 is equal to 0. That's nice because it looks like there might be a relationship between B and C. So let's see if we can follow this reasoning through. Let's consider the case where let's think of B as could B be our function? Let's think about that. Well, I know that this function A cannot be the function because A has a discontinuity at the origin. So it can't be A because A is not differentiable at the origin, so A cannot be the function. So note that A cannot be f of x. Since we're assuming in this problem that f prime exists. Since f prime exists and A is not differentiable or even defined at 0. Since A is not even defined at 0, A cannot be the derivative itself because we're assuming the second derivative itself. A cannot be f prime since I'm assuming that f prime is differentiable. At 0, 0. At 0. So the only choice for A is A must be the second derivative. So A has to be the second derivative of the function f. Now it looks like since C has an infinite derivative at 0, it looks like C has to be f prime. Because the derivative of f, the derivative of the derivative at 0 is going to be infinite. And finally, I think that B has to be our function. So let's see if this will work for us. So if B is the function, the derivative of B at the origin is 0 because B has a local minimum there. And the function C is 0 at the origin, so C, it can definitely be the derivative of f. And furthermore, the derivative of C at the origin is undefined, which is a property that A shares. So the final answer is that B is the function f, C is the function f prime, and A is the function f double prime. Thank you very much.